Good morning all. Today a teardown, or a strip down as I like to call it, of this thing. It's a Bitmain Antminer T9 Plus. So the first thing I'm going to do is take all these, I think they're called PCIe connectors out. They're just 6-way connectors with 3 yellows and 3 blacks, and I believe it's just simply 12 volts and ground, but lots of duplicates so that you get the current handling capability. So let's get all these out because the power supply is pretty big. It's this tin here. I think it's 12 volts at over 100 amps. It's absolutely crazy. So what is this thing? Well, it's a cryptocurrency mining rig. I suppose it's more well known as a Bitcoin mining rig because it has lots and lots of ASICs in it, application-specific integrated circuits, which execute the SHA-256 hashing algorithm at colossal speed. In fact, this thing here, 10.5T, means 10.5 terahashes per second. That's 10.5 trillion hashes per second. That's a lot. And this 12 volts also appears to go to this control board on the top, and that's got Ethernet. I'll show you when I get this thing out. It's got Ethernet on it, 12 volts in, and then these sort of multi-way cables which run down to the 3 hashing boards. And from what I can tell, these are just lots of TXs and RXs, so lots of serial lines communicating between the control board and the hashing board. But let's get these off as well. Now, I bought this second hand for 50 quid on eBay, and I bought it for spares and repairs, and indeed it's not working, and I've got a funny feeling it's never going to work because it looks to me like it got damaged with water. I think water got on these cables and ran down into these connectors, and the state of these connectors is not good. I'm just wondering if I can show you that. No, they all look quite shiny there, but some of these pins are quite badly blackened, corroded. I'll keep these in sequence because they some of them are better than others, but I don't know whether you can see, but there are some shiny connectors here and some rather blackened connectors, and you can see that on there. I'll probably have to twizzle the board around before you can properly see it. So that's all the cabling off. Let's take a look at, I need to take these fan connectors off, which I marked actually because I was concerned about them getting them back in the right way around. Those fans actually, interestingly, are different. There's one each end. I'll show you that when I can zoom out a bit. They're different powers. One's 2.7 amps, which is pretty fierce at 12 volts. The other one's 1.6 amps, I think. Right, let's get this power supply off the bench. It's not the original power supply. It's some unmarked, unbranded, and all the cables just come out of here. And as I say, I'm pretty sure it's just 12 volts. Put that down there, and now I can get this control board out, and we can take a look at what's on there. Let's actually start on the back because although there are quite a few bits on here, they're mostly passives, capacitors and resistors, so we won't worry too much about that. And then on the front, if we get in nice and close, we can see that this is an Antminer T9 Plus control board V1.2, and the main chip on here is a Xilinx Zinc. Now, I believe that this has FPGA type elements in it, but also 2 ARM Cortex cores, all built into this SoC, system on a chip. Now, the rest I'm going to guess because my guess is that these 2 are RAMs, or possibly these are flash memory, and this is the RAM, but I think it's one way round. Flash memory is one of them, and RAM or RAMs is the other one. We've got Ethernet connector here with the 2 little lights. We've got the now, is this a bunch of transformer couplings or something? I can't quite remember, but it's some sort of special purpose Ethernet driver module. It's not really a chip, is it? And then here it looks like that's an Ethernet controller to drive the Ethernet there. What else have we got? There are a number of switch mode blocks here, regulator blocks. There's one here with a large size inductor, and then there are a series here of 4 what look like buck converters, and this is 12 volts only on the input, so I'm guessing these step down to I'm not sure about 5, but certainly 3.3, possibly 2.5, possibly 1.8 even, and I'm not sure what the core voltage of this thing is, but it could be quite low. So these are probably all different voltage step down regulators, and have a look at the chip type on there in a moment. Now let's look at these connectors, because these are the 3 connectors that run from this control board out to the hashing boards. These 3 are a different size, and they're not used from what I can tell, but I think you can probably see the blackened pins here now. Not so much on this connector, but these 2 have quite a few blackened pins. Try and get a bit closer on that. No, so I think what happened is water dripped onto the cables, ran down into these connectors, and then just sat there for a long period of time. There's also a little bit of corrosion on some of these chip legs. I might get in a bit closer to try and take a look at that. This one looked like it had been corroded, because part of this board is exposed, part of it's under that housing, and part of it's exposed, and so it looks like water damage just got on these edges of these regulator chips. Oh, there's another one there. Not sure if that's a regulator because it doesn't have an inductor near it. We'll take a look at that in a moment. But that is essentially the control board. Now let's take a look at the hashing boards. And for that, I'm going to have to take off one of these fans. Now, something that bothered me slightly when I got this was, I don't know whether you can see this. Yeah, there's a little marking there with an arrow pointing. It's just shadowed by that, isn't it? An arrow pointing out. So this fan is blowing that way. But then when I looked at this fan, this one has an arrow. You can just about see it there. Blowing out. And that struck me as rather odd, having the 2 fans both blowing out, because that meant a huge amount of air would be sucked into this part of the grill here. And I think actually what's happened is someone has very hastily reassembled this and put this fan on back to front, because photos of these units I've seen have this wire on the inside, not the outside. So I think it was just someone's haste. But anyway, because it's not working, I think they just threw it together, sent it to me. But I mean, you know, it was only 50 quid, so what do I expect? Right, I'm going to take this end off. These miners, when they were first released, were like, I don't know, 2 grand, 3 grand. A lot of money, because when they first came out, they were capable of earning money. They ran so fast, or they run so fast, that they would make a profit in terms of cryptocurrency. But the problem is, now they don't, because the hashing difficulty has got so high, so hard, that only the very latest machines can actually make a profit now. And any machine that's slightly older than the very latest ones just doesn't make a profit. And so these things are pretty much worthless. Yeah, this has definitely had some use. It's a bit grubby in there. So this one, this is a 3D printed little sort of cowling to vent the hot air, because these things generate a lot of heat. 1.65 amps at 12 volts is that fan, and the other one is almost twice as powerful. Yeah, I think the total wattage of this thing when it's running flat out is, I think it was 1400 and something watts. And when we look at these hashing boards, you'll probably see why. So these are the ASICs, each with a separately glued on heatsink here. So how many have we got? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 times 9, whatever that is. 6 nines are 54, is it? I can't remember my times tables. But there are, of course, on the other side, a whole separate set with slightly different sized heat sinks, which is really quite weird. A lot of corrosion on this leading edge, so I don't know whether moisture got in there or whether this is just burnt dust. Not quite sure. Okay, so lots of capacitors, and there's a giant inductor here. It's only 3 turns, but it's got that sort of flat copper, enamel copper bar. And my guess is that with 12 volts coming in, the voltage for these ASICs is probably down at about a volt, maybe slightly more, but they're going to be running at a low voltage in order to get the speed. So these things are thrashing away doing this SHA-256 hashing, and I don't know, but I mean each ASIC, I don't know how many pins these things have got, but they're probably doing several sets of this SHA-256 in parallel, and then you get all these 56, what was it, 6 9s of 54 hashing chips, and another 54 on the other side. I'm guessing it's the same number, 1 2 3 4, yeah, it's got to be the same number on that side, frantically hashing the SHA-256 algorithm in order to try and find that elusive hash that has all the leading zeros. That means it's the low value hash that you're looking for. 10 trillion of those every second. So here we've got a bunch of MOSFETs here, and a little controller chip, which I'm sure are all part of this voltage step down regulator to take the 12 volts down to whatever power these ASICs need. Now, since this thing runs at about 1500 watts, each of these boards, and there are 3 of them, 2, 3, there are lots and lots of ASICs. I read that there are 171 ASICs, which sounds completely wrong. Because if there are 6 9s of 54 times 2, that's 108, times 3 boards, that's 300 and something ASICs. Don't know, I'm confused. So let's take a look at this connector, which I said was lots of serials. And the reason I said that is because, yes, right on the edge of the board there, if my camera would focus, which it might if I do that. We've got TX1, RX1, RST, TX0, RX0, TX2, RX2, and plug 0, is that? There's also an SDA and an SCL there. That sounds a bit like I2C, but it could also be some other data and clock arrangement. That I just looked up and it looked like an E2 prom. Not entirely sure about that. And then over, where is it? On the other side here, there's a DS-PIC, so a digital signal processor, so of just a very fast calculating PIC there. Oh, and another switch mode circuit here by the looks of things, probably to power this. So I don't know what all these various bits are doing, but the bulk of the work going on here is in these ASICs. And I was doing that calculation, wasn't I? 1500 watts. So each of these boards generates about 500 watts, which is why you need all these heat sinks and the fans blowing air constantly across these things to remove the 500 watts of heat generated in all these ASICs, approximately 100 ASICs per board. What would that make them? About 5 watts each. That sounds about right. Yeah, to keep this thing cool. Now, when I powered this thing up, I saw some little lights come on, and I think I've identified possibly a little LED there. I mean, you can barely see it. And I think there's another one there. So I don't think these boards are dead, but the control board certainly is dead. And I think it's not only these corroded pins that's the problem. I did put 12 volts on this board from that massive power supply, which is not a brilliantly clever thing to do, because if you short it out, you're shorting out hundreds of amps, but potentially. But I could see the 12 volts on all the inputs of all these regulator circuits, but I just could not see anything on the outputs. And I looked up this regulator chip. I'll get my magnifying glass in a moment. And it didn't look like it had an enable pin, because I thought, well, maybe they need to be switched on by the microcontroller. But no, it looked like these should just fire up on their own. And there was just nothing on any of them. So I can't imagine water getting into this would cause all the buck regulators to die, but yeah, dead they seem to be. So why did I buy a cryptocurrency mining rig that was sold for spares or repair? Well, I suppose naively I thought I might be able to repair this thing. Now I'm not so sure. When these things don't actually make a profit anymore, it costs more in electricity to run this thing, each of these 500 watt ASIC boards, than you get back in the cryptocurrency Bitcoin or all the SHA-256 Bitcoin forks that there are now. So you run this thing at a loss. You can run it at a profit if you have free electricity, but I don't have free electricity. Well, I thought if you take a different look at this, a different approach to this, and my view was, let's look at this as a heater that could heat a shed, for example. So you'd switch it on. You can set the clock rate of these things to generate more or less heat. That's not really the aim of it. The aim is to generate more or less Bitcoin. But I thought I could heat my shed and actually get cash back. So I didn't buy this really as a cryptocurrency miner because it's worthless in that regard, which is why I got it for 50 quid. As I say, these things were 2 or 3 grand when they first came out. No, I bought this as a shed heater with cash back. Oh, wait a minute. I don't think there's a gap there, but there is a gap there. It's hard to see unless I get the light on it. So I think the ASICs are on this side of the board and they're not on this side of the board. I think these are just heat sinks glued onto the back of the board for additional cooling. Otherwise, it wouldn't make sense that these are monster great heat sinks and these are little tiddly heat sinks. Yes, so actually, come to think of it, I think there are 56 ASICs per board, which gives you a grand total of 168, is it? Yeah, 168 ASICs, I think. That's interesting because I've definitely read on some websites that this thing has 171 ASICs. So they counted one additional ASIC, and I think they may have included the DS PIC, which of course is a microcontroller. So no, it's definitely 168 ASICs and 3 digital signal processors. So that's what's inside an Antminer T9 Plus. Let's get these hashing boards back in. 3 hashing boards and a controller board. Let's get another hashing board in there. Yes, I'll show you what the end of this thing looks like when I've got these 3 boards in, because it looks quite fun. Yes, an industrial grade cryptocurrency mining rig. Oh, they're a very good fit in this box, aren't they? Very small clearance there. And the heat sinks, yeah, small clearance there, and another one there. This was quite thought out, I think. Someone spent some time thinking about this. Force air through all of this lot to draw that energy off these things. So, yes, shed heater, because as I say, this thing at full tilt will kick out 1430 watts, I think it is, and earn a bit of money back in the process, rather than just going and buying, you know, some sort of convector heater or oil-filled radiator. Use a cryptocurrency mining rig. And then this thing fits in this little housing. You've got to pull these springs back, which is quite hard to do with one hand. Oh, I think it goes in like that. That's it. And that clips in there. And then, as I say, these 3 connectors link to the hashing boards. And then you just need to put lots and lots of 12 volts onto this thing to give it the current it needs. I was going to have a closer look at these regulators, wasn't I? Let's see if we can see the number on there. I'll try and get it in the light. Oh no, there we are. I think it's a VUB1, and I did look this up, and it looked like a fairly standard off-the-shelf regulator. Can you see that better on one of these? No, not really. But one of them, I think it was this end one, looked like the pins had got a bit corroded on the end, and this one here looked like some corrosion had appeared on the end, but I don't think that would have killed all of these regulators, unless there is an enable pin. Maybe I'll need to take another look at that. Maybe I'll do another video where I put some 12 volts on here, and I'll probably put it on here from a current limited power supply, so that if I accidentally short something while I'm fiddling about, I don't short 100 and whatever it is amps coming out of that massive power supply. But that was a quick strip down of an Antminer T9 Plus, 10.5 terahashes per second cryptocurrency mining rig. Cheerio.